The hydraulic brake system is an essential component in modern vehicles ensuring safe and efficient stopping power. Our project demonstrates Pascal's principle through a working hydraulic brake system model wherein fluid pressure is used to transmit force and stop the motion of a rotating wheel. Our model is designed like a car wheel with a braking mechanism inside the rotating circle. And by pressing the syringe here, water moves through a transparent tube transferring force to the brake system, which slows and stops the rotation. Additionally, we incorporated a pedal-like acceleration and braking system by attaching small square cardboard pieces to the buttons, making them resemble car pedals. Now when step on the acceleration buttons, it will start the rotation while the brake buttons stops it.
To build our model, we use simple materials such as cardboard for the wheel, illustration board for the base, and a syringe and transparent tubing and water as the hydraulic fluid. We also add small cardboard pieces to the button to simulate an acceleration and braking pedals. Now, let me walk you through the process of how we build this model. First thing is constructing the wheel. We start by creating a circular cardboard wheel that can rotate freely just like a real car wheel. And the second we do is installing the brake system. Inside the rotating wheel, we place a small syringe mechanism, and the two handles of the syringe are connected through inside a single tube, which is then linked to a transparent tubing. Third is setting up the hydraulic system. So we fill the tubing and syringe with water to allow a smooth transmission of force. And the last thing we do is adding the acceleration and brake pedals. For acceleration, we attach a small square cardboard pieces to a button mimicking a car gas pedal. Pressing this make the wheel spin. For braking, we attach another cardboard pieces to a syringe handle and pressing it push fluid through the tube, activating the brake and stopping the wheel.
Our model operates based on Pascal's principles, which states that when a pressure is applied to a confined fluid, it is transmitted equally in all directions, and by pressing the brake syringe, it increases the fluid pressure inside the system, and yung pressure pong iyon is nagtra-transfer po siya ng force doon sa syringe inside the wheel na nag-engage na nga po nung brake, kasi po yung brake pad is natutulak po siya against the rotating wheel as the pressure increases. And when the pressure is released naman po, is it will allow the wheel to rotate freely again. Kasi nga po yung brake pads na natulak kanina is aatras po siya pabalik doon sa dati niyang pwesto. And this system closely resembles real-world hydraulic brake mechanism used in vehicles, effectively demonstrating fluid mechanics in action.
One of the limitations of our hydraulic brake is that its structural weakness. So the cardboard cannot match metals or plastic in terms of durability and strength, so it will be deformed easily under pressure. The second limitation is the fluid containment, because cardboard is not waterproof, so it can be soaked up in the hydraulic fluid that could lead to leakage and system failure. Lastly, it has a short lifespan because the hydraulic brake is made of cardboard that makes it unreliable for long-term use. Also, it has a rechargeable battery that we cannot use it if we do not recharge it, so that wheel will not turn and we cannot use it if we demo it. So in terms of the uniqueness, so our hydraulic brake is unique because of its eco eco-friendly material, which emphasizes sustainability and reduces environmental impact compared to conventional hydraulic system. Its lightweight construction makes it easier to handle and assemble, offering a practical alternative to heavier metal or plastic. So lastly, it is a low-cost alternative because it can be built using inexpensive materials, making it accessible for experiment, education, and small-scale projects.
This principle is the foundation of our hydraulic system, widely used in transportation and industrial machinery. Hydraulic brakes are crucial for vehicle safety as they provide a smooth and efficient stopping powers in car, motorcycles, and airplane. They also play a vital role in construction and industrial machine, ensuring controlled movement in cranes, bulldozer, and forklifts. Beyond transportation, hydraulic systems are used in elevator, medical equipment, and rescue operation, making everyday life safer and more efficient. This project is significant because it gives us hands-on experience in understanding fluid mechanics and engineering application. By constructing this model, we gain insight into how hydraulic systems work and appreciate their impact on modern technology. It reinforces the importance of science in creating safer and more efficient machines that improve our daily lives.
Now, let's proceed to the discussion of results and observation. We observe na kapag light press lang po yung ina-apply doon sa brake is gradually slowing lang po yung pag-rotate ng wheel, and it takes 1 to 2 seconds for it to actually stop. And kapag full press naman po ang in-apply doon sa brake is automatically tumitigil sa pag-ikot yung gulong. Kumbaga po, immediate stop po yung nangyayari around 0.5 seconds. And kapag wala naman pong brake applied is continuous rotation lang po yung nangyayari sa wheel. Sa components naman po ng aming model is we observe na it is better to use transparent tube kasi nga po it allows clear visualization of fluid movements, reinforcing Pascal's principle. Second is maganda po yung naisip naming pedal-based system kasi po it improves user interaction, making it more intuitive and engaging. And lastly, kapag may positive side po is meron ding negative side kasi through the process of making our project is we undergo trials and errors po. May mga na-encounter po kaming problems na resolbahan naman po namin at the end of the day. And first dyan po is yung minsan po hindi umiikot yung wheel kasi nga po nakakasabit yung cardboard na kaagad naman po namin ina-adjust. And yung worst po na na-encounter namin is yung by the time na nilagay na po namin yung fluid doon sa tube is some leakage was observed doon po sa syringe and tube connection, which we resolved by reinforcing the glue. Pero po nung naubos na namin yung isang glue stick is still may leakage pa din po ng fluid, kaya we had no choice po but to replace the syringe and tube with a new one na nag-result naman po sa better outcomes. In conclusion, through this project, we successfully demonstrated the working principle of a hydraulic brake system, highlighting fluid pressure transmission and force application na by replicating a real car's braking mechanism with an interactive and innovative model, we effectively illustrated the practical applications of Pascal's principle. This project enhanced our understanding of fluid mechanics and yung role po niya sa modern engineering, particularly in vehicle safety. And we also learned na yung combination po ng cardboard-based components and hydraulic elements proves that even po pala yung mga simple materials, it can effectively demonstrate and explain complex scientific concepts. So, for the future improvements, it could include stronger tube, large syringes for the brake, a more viscous fluid such as oil for more realistic braking performance, and lastly is the use of hard materials such as plywood instead of cardboards para po mas mataas yung durability ng project.